Hi everyone. In this video, we're going to study more sample problems regarding logarithmic functions. Let's have example 1. Simplify each of the following using logarithmic properties. Letter A, log of 1 to base 16. Letter B, log of 125 to base 5. Letter C, e raised to log of 10 to base e. Let us write the properties that we're going to use to simplify the given problems here. For letter A, the log of 1 to base 16, we're going to use property number 1. It says here, for any base, and we're going to get the log of the number 1, the answer is always 0. So this is equal to 0. I will go to problem B. The log of 125 base 5. I'm going to use the property number 3. However, I need to do something to 125. I need to show that this 125 is equal to 5 cubed. So I have now log of 5 cubed to base 5. And as per our property number 3, we can simplify this into that exponent. So the answer here is 3. For problem C, the e raised to log of 10 to base e, we're going to use property number 4. And the answer here is the value which is 10. So the answer here is 10. So these are now the final answers. Let us go to example 2. Expand using the rules of logarithm. So this is log of a fraction where the numerator is 4x cubed z squared all over the denominator is y raised to 5 to base b. So this is taking logarithm of a quotient. So what we'll do is to get the log of the numerator minus the log of the denominator. So we have now log of 4x cubed z squared, that is the numerator, to base b, then minus the log of the denominator y raised to 5 to base b. In our first log here, there is a product, and to simplify that, we need to get the sum of the log of each of the factors. So let us expand this now. So we have log of 4, the first factor, to base b, plus the log of the second factor, x cubed, to base b, then plus the log of the third factor, the z squared, to the base b, then the minus log of the denominator, the y raised to 5 to the base b. We simply copied this last part here. So we have now 4 logarithms here. We can observe that there are exponents in each of the variables for the log here, here, and here. And we can still simplify that by making this exponent to be a factor of the log. So this is equal to the log of 4 to base b remains the same. Now for this log of x cubed, the exponent 3 we will put down here. So we have 3 log of x to the base b. then plus the power 2 comes down as a factor, so we have 2 log of z to the base b. Then minus the exponent 5 comes down as a factor, so we have 5 log of y to base b. So this is now our final answer. Let us have example 3. Write the expression in terms of a single logarithm. So we have 2 log of x to base a plus 5 log of y to base a minus log of z to base a. We can observe here that the first 2 logarithms have constant in front of them. Here is number 2 and the other is number 5. We can simplify this by putting this constant as a power of the x. So let us write the problem again into log of x squared. Number 2 becomes the exponent of x to the base a, then plus the log of y raised to 5. Now the constant 5 becomes the power of y. And this is again to base a, then minus the log of z to base a. Then let us combine the first 2 logs. Because of this positive sign, we can put them as a product. So we have now the log of the product x squared y raised to 5 to the base a. And this log of z to base a, we just simply copy here. And to simplify further, this negative sign here denotes division, so we will put the 2 logs as a quotient. So we have the log of the fraction. First is the x squared y raised to 5 as numerator divided by the z, which becomes the denominator, and this is to base a. This is now our final answer. Let us have example 4. Solve for x. So we have here log of x to base b plus the log of the binomial x plus 1 to base b equals the log of 20 to base b. So this positive sign denotes product for the x and the x plus 1. So we will combine them. So we have now the log of the product x times x plus 1 to the base b equals, the right side is still the same, the log of 20 to base b. We have property number 5 that says the log of capital M to base b is equal to the log of n to base b if and only if m equals n. It means to say, since both the left side and the right side is a logarithm to base b, we can remove the logarithm directly to both sides. So you see here, the x times the x plus 1 comes down equals the 20. And from here, we will solve for x. We will distribute this x to each term of the binomial. So x times x is x squared. X times 1 is positive x. Now, for this 20, we're going to transpose on the left side of the equal sign, and the positive 20 becomes negative 20. And this is equal to 0. From here, let us solve by factoring. And the factors of x squared plus x minus 20 are x plus 5 times x minus 4, and this is equal to 0. And then for each factor, we will equate into 0. Let's start with the x plus 5. This is equal to 0, and the x minus 4 is also equal to 0. Then let us simplify both equations. X plus 5 equals 0. We will transpose the positive 5 to the right side. So we have x equals negative 5. And the other factor, the x minus 4, we will transpose the negative 4 to the right side. We have now x equals positive 4. And these are the values of x for the given problem. Let us have example 5. Solve for x. We have e raised to 1 minus 3x equals 9.62. From property number 5, it says the log of capital M to base b equals the log of capital N to base b if and only if m equals n. In this equation, we are going to apply logarithm to both sides of the equation. But since this is a variable e, we're going to apply a log with base e. So we have log of e raised to 1 minus 3x to base e equals log of 9.62 to base e. We did put e as the base for the log because we want to use property number 3 that says the log of b raised to x to base b can be simplified into x, and this x is simply the exponent of the b. It means to say we can simplify the left hand side. We can simply put the 1 minus 3x down here, and this is now equal to the log of 9.62 to base e. I hope you still remember about the natural logarithm, that the log of x to base e is equal to the ln x. It means to say the log of e, we can change this by the ln symbol. So we have now the 1 minus 3x equals the ln of 9.62. Using our calculator, we can get the value of the ln 9.62, and this is equal to 2.26384. So let us now solve for x. This positive 1 we will transpose on the right side. Of course, the sign must be changed. So we have now the negative 3x equals 2.26384 minus 1. See here, the positive becomes negative 1. And to simplify further, we will get the difference of the two numbers here. So we have negative 3x equals 1.26384. And to make the coefficient of x equal to 1, we're going to divide the equation by the coefficient of x, which is negative 3. And if we do that, the negative 3 here will cancel out. So we have x equals the 1.26384 divided by the negative 3. And we can now simplify this into negative 0.42128. And this is the value of x that we are looking for. This is our final answer. I hope you learned something from this video. See you again next time.